In the world of AI, we always hear this one thing: bigger is better, right? More data, bigger computers, giant models. But what if that's wrong? Or at least not the whole story. Today, we're going to look at a breakthrough in robotics that totally flips that idea on its head. It shows us that to get really smart robots, maybe, just maybe, we need to think a little smaller.
So, for the longest time, robots have been, well, kind of dumb, but really good at one thing. Picture that factory arm on an assembly line. It can do the same exact move 1,000,000 times, perfectly. But, ask it to pick up something that's slightly out of place, the whole thing just stops. The real dream, the thing everyone in robotics is chasing, is a robot you can just talk to. One that can actually see the world, understand what's going on, and deal with all the messy, unpredictable stuff in real life. That huge leap is what we're diving into.
Okay, so how do you even start to build a robot like that? Well, the idea is you have to give it one unified brain, and that's exactly what a Vision Language Action Model, or VLA for short, is all about. It's an AI that connects three crucial things. First, what it sees with its cameras, that's the vision part. Second, what you tell it to do in just normal everyday language, that's the language. And third, it translates all of that into actual physical movement, the action. See, think, do. It's that whole cycle all rolled into one single powerful model.
All right, here's what we've got on deck. We're going to look at the huge promise of these smart robots. Then we'll meet a powerful but kind of clumsy giant of an AI. After that, we'll dive into two really big ideas about how robots can think and see better, which leads to our grand finale, a smaller, faster, smarter solution. And finally, we'll talk about what this means for the next generation of robots. Let's do it.
So yeah, the promise here is just huge. We're talking about finally getting robots that can step off the factory floor and actually work in our world, our messy, unpredictable homes and offices, and understand what we want just by talking to them. It's a total game changer. And to try and make this dream a reality, researchers built this absolute beast of a model. It was called MiniVLA. I mean, this thing was a huge deal. A super powerful, open-source AI brain. But like a lot of giants in stories, it had a big, secret flaw. One that was basically keeping it locked away in the lab, unable to be useful in the real world.
And that flaw? It was just its size. OpenVLA had a staggering 7 billion parameters. Now, you can think of parameters as all the little knobs and dials an AI tunes to learn things. So with 7 billion of them, this model was like a concept car with this ridiculously huge engine. Yeah, it's super powerful, but it's an absolute gas guzzler. It just needs way too much computing power to be practical for, anything.
And if we peek under the hood a little, you can see just how complex this thing was. It used some really cutting-edge stuff for its vision system. You see DNOV2 and SIGLEP there. But the real heavyweight, the part that was causing all the trouble, was its language model, the massive Llama 2. That's where all 7 billion of those parameters came from. It was the source of its power for sure, but it was also its Achilles heel.
So what you have is this giant brain that was just too big to function properly in the real world. It was slow. We're talking only about 5 cycles per second, which is nowhere near fast enough for smooth, fluid movements. It cost a fortune to train and run, and you couldn't even put it on normal, affordable computer hardware. So that was the problem, right? This brilliant AI mind was trapped inside a body that was just too slow and expensive to ever leave the lab.
Okay, so how do you fix a problem like that? Well, a team from Stanford came up with a really clever solution called MiniVLA, and this is really the hero of our story today. Its power comes from two incredibly smart ideas. So let's break down that first big idea right now.
Their first move was pretty bold. They just shrank the brain. A lot. MiniVLA is 7 times smaller than OpenVLA. It went from 7 billion parameters all the way down to just 1 billion. And they did it by swapping out that giant Llama 2 language model for a way smaller, more efficient one. But that leads to the obvious question, right? How on earth can it be that much smaller and still be just as smart?
Well, the secret sauce is all in how it thinks. See, the old way, the way OpenVLA did it, was to predict one tiny little movement at a time. It's kind of like trying to speak by spelling out every single letter. It's just painfully slow. MiniVLA does something way smarter. It uses a technique, and yeah, it's a mouthful. It's called vector quantized action chunking. But what it does is learn to think in whole, complete motions. It predicts an entire action chunk all at once.
And this quote from the research paper just nails the idea perfectly. It's exactly like teaching the robot to speak in whole words instead of spelling everything out letter by letter. So instead of thinking M-O-V-E left, it learns a whole vocabulary of complete moves, like the entire action of pick up the cup. It's way more efficient, the movements are way smoother, and because it's a smarter way to think, the brain itself doesn't have to be so massive.
Okay, so shrinking the brain and teaching it to think in words instead of letters was a huge step. But that wasn't the whole story. To really go toe-to-toe with the giant model, MiniVLA also needed to get a serious upgrade in how it sees the world. The issue with the older models is that they were basically operating with blinders on. For every single decision it had to make, the AI got just one single, static picture of what was happening. I mean, imagine trying to do something like tie your shoes, but you can only open your eyes for a split second every few seconds. It'd be almost impossible, right? Well, that's pretty much the situation OpenVLA was in. So MiniVLA's solution is just brilliant and simple. Instead of that one lonely snapshot, it gets 3 different views of the world. First, it's got its main camera, which sees the big picture. But then, and this is key, it also gets to see the last few frames from that camera. This gives it a kind of short-term memory, so it understands motion. And then, for all the tricky, precise stuff, it has another camera right on its wrist, giving it a perfect close-up of its own hands. And this wasn't just some nice-to-have feature, the numbers back it up. Just adding either that video history or the wrist camera boosted the robot's success rate by about 5%. So giving it a better, more complete view of the world made it quantifiably better at its job.
All right, so let's recap. We've got 2 big, clever ideas here. A smaller brain that thinks in complete thoughts, and a much better way for it to see. So, did it work? Did our little MiniVLA actually manage to take on the giant?
The results are, and I'm not exaggerating, pretty stunning. They tested this on a really tough benchmark. It's called Libro 90, that throws all sorts of complex tasks at the robot. The giant OpenVLA scored a pretty good 82% success rate. So what about our hero, MiniVLA? Well, even though it's 7 times smaller, it scored exactly the same. All that performance in a package that's a fraction of the size. This is a really, really big deal.
So think about that. MiniVLA isn't just as good as the giant model. In the ways that really count, it's actually better. It gives you the same performance with way fewer parameters. And because it's so much more efficient, it runs 2.5 times faster. And that speed, that is absolutely crucial if you want a robot that can react smoothly and safely in your home.
So, we have a smaller, faster AI brain that performs just as well as the massive one. That's a super cool technical achievement for sure. But what does it actually mean? Why does this matter for the future of robotics and, well, for you and me?
The big takeaway from all of this is pretty clear. It's not just about raw power anymore. It's about efficiency. That's the real key to unlocking the next generation of robots. Because smaller AI can run on cheaper, normal hardware. Faster AI means robots can react instantly, which makes them safer and way more useful around us. At the end of the day, it's these kinds of clever, efficient designs like MiniVLA that are going to be the things that finally get these general-purpose robots out of the lab and into the real world.
And that really brings us to the final and maybe most exciting question. For years, the dream of having a helpful robot in the house was blocked by a few big things: cost, safety, and just raw intelligence. But by proving that a much smaller, way more efficient AI brain can be just as smart and powerful, projects like this are knocking down those barriers one by one. It really makes you wonder, doesn't it? With AI brains getting smaller and smarter this quickly, how long is it really going to be before one of these helpful robots actually shows up at your door?